Welcome to the use case demonstration of CAS software from Karlsruhe. We are going to present you our solution SmartWe, a customer relationship management system, and how it is deployed by using the Melodic Cloud. You're going to see the following features. Security, where we assure based on a policy that deployments, for example, are only made within our business hours. Docker deployments, since all our components are provided as Docker images. Bring your own node. This means that we have a predefined node that's then used by Melodic to deploy parts of the infrastructure to exactly this node. This is necessary because in case of one of our components, there are certain requirements that are host specific, so we have to provide them before the actual deployment is happening. Multi-cloud deployments, as well as cross-cloud deployments. We have utility-based deployment optimization, of course. So in our case, we are aiming for the cheapest deployment solution possible while providing the most free RAM as possible. You will see built-in metrics such as the RAM sensor, and we are going to show you the user interface and visualization. So Melodic is already running and the user interface can be used. I am going to log in now. It's an authorized, authenticated process. We have already created an LDAP user that is then considered by the UI. So it's actually possible that way to set up several users, for example, the team in our deployment department, that can then, with different rights, use the Melodic UI. Okay, what we see here is the Melodic UI. You have on the left-hand side the existing menu points, such as deployment. You can gather information about the process that are currently running, the application, already deployed artifacts, and so on and so forth. Since we are going to start with a fresh deployment, I am entering the deployment section. We can now upload our predefined application camel model, and I'm going to do that. The model has, in its XMI representation, around about 220 kilobytes, and the upload process is going to take a few seconds. So while this is running, I would like to show you the model in its camel representation. We are using the Eclipse-based editor, and what we are seeing here is we have our overall application model containing several component definitions. We have, for example, Smart Design. This is our front end. It has certain requirements such as ports in both directions, in and out. It specifies a Docker image. It's taken from a private repository, so it needs also some credentials that are provided here. It specifies some resource requirements. We can have a look at them now. So we define a resource between 1 core and 2 cores, and a memory requirement between at least 8,000 megabytes with a maximum of 12,000 megabytes. We have requirements for the operating system image where our Docker hosts are then installed onto. We have requirements for whether our resource is of type private cloud or public cloud. This is important because in the CAS use case, we have certain components that we want to be installed on private resources, whereas others can be installed on public resources because they do less sensitive workloads. We have a requirement to be fully located in Europe. This has also to do with the GDPR, of course. And yeah, it works similarly for all other components. So we have defined system requirements, operating system requirements, and location requirements. Furthermore, interesting to see are the horizontal scale requirements. We have most components in just one instance, but there is the smart design component that you have seen already, the front end, where we would like to start with 2 components and reach up to a maximum of 6 components if needed. And this has to do with the scaling aspect of our use case. We would like to react to increasing RAM usage because it's the aspect that affects most the user experience. So the more users we have on our smart design instances, the more RAM usage it causes, of course, and yeah, this slightly affects the overall performance and the speed that the user experiences with the system. Then we have, of course, the cost utility plus scaling rules that actually define when exactly a scaling event has to happen. So I'm going to show you the scaling formula. We first calculate the total mean RAM usage that is then used to calculate whether this still is within the bounds of having not more than 80% of RAM actually used by the current deployment situation of the front end. And to give you a better overview before I start the actual deployment, I would like to show you this graphic. It represents the model that we have just seen in Eclipse, but in a graphical way. So you recall we have the smart design front end component, plus we have a load balancer. Since we are starting with 2 components and we are reaching up to 6 components, the load balancer is important to distribute load, of course. We have the so-called open server. It's our CRM backend. The open server has a database, of course, plus there is an external component attached to it. It's called the Picasso search or smart search. It's basically a search engine that works on our data and provides it via an API that is then consumed by our CRM system. So you can do things such as full text search, you can search for data types, you can search inside data type instances, for example. So it's a powerful tool to provide you a good experience when searching for things. Okay, we see now that the model is uploaded for quite some while now. We can go to the next step and define which cloud resources should be considered for this certain deployment. And I have told you, in our case, it's AWS. So I will do check AWS, plus we are using a private OpenStack installation. So I will check mark this as well. And we are using a pre-configured node, so-called Bayern, bring your own node concept of Melodic. And we will add this one as well, so that Melodic can then take these definitions and the resources provided by these clouds to make its decisions. Good, okay, this was done. So we can go over to the next step, the actual deployment. By hitting the green button, the Melodic process of deploying starts. So, what happens now in the background? Well, Melodic is currently fetching offers. What does that mean? You have seen we have configured the AWS cloud, we have configured the OpenStack cloud, and we have configured our own node. So Melodic now is traversing these cloud providers, asking them for their current offerings. So you can imagine there is a machine, let's say, of type M2 small provided by AWS. There is a type M2 medium, M2 large, and so on and so forth. So even though we have only 2 cloud providers here, there are quite some possible offerings that Melodic has to consider. And this is why it's going to take a moment. We can, in the meantime, for example, enter this offering part of the UI and check again that we have the important clouds that we want to be considered, indeed considered, and that's OpenStack and AWS. This is looking very good. We can see if there was already some hardware discovered, and yes, this is the case. We have instances here representing different compositions of hardware. For example, the C1 medium, it offers 2 cores, it offers round about 2 GB of RAM, a 10 GB disk, and we also have several locations. I have explained before, in our deployment, we want to have the whole deployment being done within Europe because of the GDPR and our company policy. So in our case, Melodic is forced somehow to choose only offerings that are located within Europe. Additionally, there are images. I have explained that when I introduced you to the camel model. There are, you can imagine, for basically every Linux existing, there is an image for it. There are also Windows images, of course, but they are less relevant for our use case. So Melodic, in our case, will probably choose the Ubuntu 16.04 for the machines, will then install Docker on top of it and perform the deployments. Okay, let's go back to the process view. Okay, we see that fetching offers is done, of course. We had Melodic generating the constraint problem. So you remember we had certain requirements for our application, such as RAM and CPU cores. So Melodic kind of narrows down the overall amount of offers to kind of filter out only the relevant ones that fit regarding their hardware requirements. Then, as a next step, Melodic is going to choose the offerings that are the best fit for our application components. So the amount that was also narrowed down in this generating constraint problem step are now further reduced. And it seems that Melodic is in the deployment stage now, so this means that Melodic has chosen concrete offerings for each component. So what is happening now? Melodic contacts the cloud service provider to allocate the resources and to roll out our installation. I have explained you before that we have the application view where you can see easily what applications Melodic actually considered. In our case, we have these components consisting of the load balancer, of our OpenCRM backend, the Smart Design front end, and you can see of the Smart Design front end we have 2 instances. This is because in the camel model we specified exactly that. We want to start with 2 instances and maybe, if needed, scale up till a maximum of 6 instances. So that's as expected, that's very good. We have the Smart Search or Picasso, we have the Elasticsearch, and we have a database. The database is obviously going to need a bit more time. I will press F5 to refresh. Okay. The database is now present as well. You can also see which provider was actually chosen. So OpenStack for the database Of course, this makes sense because we want our database to be hosted on a private resource because it contains sensitive data, and this is just complying with our company policies and the GDPR, and that's why it was modeled in that way. We have Elasticsearch being deployed on our own node. This is why here you can see unknown, but the city is Karlsruhe because we are hosting this instance near to our premises. Then we have several components being hosted on AWS, such as the load balancer, the CRM backend, and our front-end instances. And we have the Smart Search. It's again a more sensitive component because it accumulates a lot of sensitive data, and we want this instance to be hosted on an OpenStack private cloud resource. So I'm going back to the process view. The state deploying is still ongoing. This is because imagine Melodic is now really contacting resource after resource, connecting to it, installing Docker, downloading the Docker images that were specified in the camel model, and executing it. And also an important step that's happening in this phase is that the components are wired up. You can imagine one component has a relationship with another component. They're using a certain port to communicate with each other. So Melodic makes sure that the load balancer knows the IP plus the port of Smart Design. And that Smart Design, again, knows the port and the IP address of the OpenCRM backend, and so on and so forth. So basically, Melodic has to take care that every component knows all the other components it's going to have direct contact. Okay. What I would like to show you in the meantime, while the deployment is finishing, is the process view based on processes that are happening within Melodic. So we have, for example, and you know Cloudiator is the executionware part of Melodic, the so-called Cloudiator queue. And what we can see here is all the jobs that Cloudiator has to perform, asked and ordered by Melodic, are being executed one after another. So we have some that are completed already, there are some that are still running, and these jobs are things such as allocate this resource, set it up, download the container, start it, and so on and so forth. Then we have processes. So queues are basically the more fine-grained view. Processes are, let's say, a hierarchy step above them. So we have a process for basically each component, and we can also see whether they are still running, whether they are pending, and so on. We have then Cloudiator nodes. So this is just another way of representing the already allocated resources. This shows again that we have, we have three overall types, such as private cloud, public cloud, and owned node or Bion. Cloudiator distinguishes this between a regular VM, such as an OpenStack or AWS VM, and Bion, our own node, so to say. And just for your interest, Melodic or Cloudiator are contacting these VMs via SSH. So when the resource is allocated, an SSH key is generated and then used by Melodic to contact the VM to perform commands to set up, for example, the Docker installation, and so on and so forth. So all processes are running. Another look in our Cloudiator queue. all statuses show that the tasks are completed. So we go back to our overall process view, and it's probably a matter of another few seconds or 1 or 2 minutes until the final state is reached. Okay, and this just happened. So we are now having a fully functional SmartWe CRM deployment situation. Okay, what does this mean? Well, I'm going to show you first of all that we can contact the application. So we are starting with the load balancer. I'm copying the URL. And I am invoking it in the browser. So the load balancer now redirects my request to one of the Smart Design CRM front-end instances, and that just happened. So I can now log in into the SmartWe CRM application. So now the front end is making contact with the back end with the database, and so on. So all the components that were deployed are now involved in actual activity. And while the SmartWe application is loading, I would like to show you the visual aspects of our deployment. We're using Grafana here, and I'm going to change to the last 15 minutes. So what do we see here? Well, on the left-hand side, we see the raw RAM usage per component. And since in our case, the front end is the component we're interested in, this dashboard shows exactly these two components. The orange one is one front-end component, and the green one is one front-end component. The blue line that you're seeing in this diagram represents the mean value over all existing front-end instances, and it's currently around 82% of memory usage. So, and I have told you that we would like to assure that memory usage never exceeds a certain threshold. In this case, we've set it to 90%. So if we would have an increase from these 82% to 90, Melodic is going to deploy or to add another front-end instance in order to relax the situation. And I'm going to simulate that now. You can see this is the application that I've just logged into. I'm going to explain you something more about that after we have scaled. Okay, I'm going to scale by actually connecting to one of the Smart Design instances, and I'm going to use a bit of stress onto this machine by increasing RAM load to 95%. So I'm installing a stress tool, it's called stress, and it's running now. So we're now going to see that this instance is climbing up. It's just going to take a few seconds. Until it's visible. Okay, we can see that now. So the first instance, the green one, already exceeded this limit of 90% over RAM usage. The average will take a little bit more, and to make sure that this is happening fast, I will also connect to the second instance of Smart Design and increase RAM usage there as well. So we see that now the average also climbs up. We will see in a few seconds that the second machine shows an increase as well. Meanwhile, you can see on the right hand side that we have a dashboard that represents the average RAM usage per region. In our case, our deployments were done in Germany. So you remember the rule was within Europe, and yeah, Amazon obviously choose Germany for that. And we have an average of 87, yeah, roundabout percent. So imagine we have in the future components distributed over whole Europe. It's a nice way of finding out which region is in what state. So basically, it's up to your creativity what you model, what kind of dashboard you introduce. This is an example on how we did it. So you can see that the average memory consumption now exceeded the 90% and a scaling event was triggered. So this is basically the order for Melodic to now find a better solution, to improve the current solution. Because, as I mentioned already, increased RAM on the machines means the customer experience to be slightly worse the more RAM is used. So it usually takes around about 3 minutes until the machine is available. So I'm afraid that we have to wait a little bit more. I'm going to switch back to the application view. We have 7 applications here. We should soon have 8. Okay, it was done. We have now 1 instance of Smart Design, 2 instances of Smart Design, and 3. So a third one was just added. I suppose it will take another 30-60 seconds until the new instance will also show up here in Grafana. It already indicated that there are now 8 instances, so that's 1 instance more than before. But this instance is not yet running, so it means that there is not yet a RAM sensor injected and available, not sending yet. So this is why it doesn't show up here yet. You can see, meanwhile, this average RAM per region also turned red to indicate that it's in a critical state. Meanwhile, I will show you a bit the application. So you can basically do things such as adding contacts, giving them a name, maybe an organization, a picture, and so on and so forth. You can also upload documents. I would now like to show you the Picasso search. You remember that the Picasso search consists of a microservice called Picasso or Smart Search and an elastic stack component holding and providing the data. So how does that look like? There are 2 options. You can use this top bar search, and I can search for a word. For example, if I want to find all lunch appointments that I have in my calendar, I would just type that in, and the results would then be presented to me. Another way of using the Picasso search is by using the Picasso app. And the Picasso app is yeah, a nicer representation of search results than this top bar search, but the concept is working similarly. I can search for a certain word or for a combination of words and get my results, navigate to them, yeah, just in a way that is presented a bit nicer and more intuitive maybe. We now see that the third instance was brought up. It's the yellow one here on the right hand side. And yeah, we can also see that the orange, that's now the average RAM, is climbing down. So it improves. The overall RAM usage improves, and so does the user experience. Okay, yeah, based on this demonstration, I hope that we could give a good, nice overview on how we at CAS Software use the Melodic platform and how it helps us to scale our applications based on the need that currently occurs. So in this case, based on resource consumption caused by users or by huge numbers of users using our system. Thank you very much